You're standing in your kitchen with a 100-pound sack of potatoes. They're fresh from the farm, plump with moisture, and exactly 99% water by weight. You leave them on your counter overnight, and by morning, they've dried out. Now they're 98% water instead of 99%. Here's the question that will break your brain. How much do your potatoes weigh now? If you're thinking 99 pounds, obviously, congratulations, you've just fallen into one of mathematics' most delicious traps. The correct answer will shock you. 50 pounds. Your potatoes lost exactly half their weight when the water content dropped by what seems like an insignificant 1%. Let's first establish why this paradox feels so wrong. In our everyday experience, losing 1% of something means losing roughly 1% of its weight. If you ate 1% of a pizza, you'd expect the box to be 1% lighter. If 1% of your bookshelf collapsed, you'd lose about 1% of your books. But water weight doesn't work like pizza weight or book weight. Water weight is what mathematicians call a proportion, and proportions behave in ways that violate our intuitive understanding of parts and wholes. Consider real vegetables for a moment. A standard potato is actually about 79% water by weight. Watermelon? That's 91% water. Lettuce is nearly 95% water, meaning your salad is essentially water with a 5% garnish of actual plant matter. Those numbers sound high, but they're nothing compared to our paradoxical potatoes at 99% water content. Let's construct the paradox with mathematical precision. We start with total weight, 100 pounds. Water content, 99 pounds of water. Dry matter, 1 pound of actual potato stuff. That single pound of dry matter includes everything that isn't water. Starches, proteins, pectins, minerals, fibers, and all the complex organic compounds that make a potato taste like a potato instead of like water. Now, overnight evaporation occurs. Some water molecules escape into the air, but here's the crucial point. The dry matter doesn't change. Evaporation only removes water. But now, the proportions have shifted. Instead of being 1% of the total weight, that same 1 pound of dry matter represents 2% of the total weight, because the water content has dropped from 99% to 98%. The obvious but wrong calculation goes like this. Well, we lost 1% of the water content, so we lost 1% of the total weight. 1% of 100 pounds is 1 pound, so the answer must be 99 pounds. This reasoning feels mathematically sound because it follows the mental model we use for most real-world calculations. If you have $100 and spend 1% of it, you have $99 left. If you have 100 pages in a book and lose 1% of them, you have 99 pages left. But water percentage isn't measuring 1% of the original water. It's measuring water as a percentage of the current total weight. This creates a feedback loop that our brains aren't wired to handle intuitively. Let's test the 99-pound hypothesis mathematically. If our potatoes weigh 99 pounds total and they're 98% water by weight, then water weight equals 98% of 99 pounds, which is 97.02 pounds. Dry matter weight equals 99 minus 97.02, which is 1.98 pounds. But wait, we established that the dry matter couldn't change. We should still have exactly 1 pound of dry matter, not almost 2 pounds. The 99-pound answer creates a mathematical impossibility. The key to solving this paradox is to track the one thing that doesn't change, the dry matter. We know 3 facts for certain. We start with 1 pound of dry matter. Evaporation cannot create or destroy dry matter. Therefore, we end with 1 pound of dry matter. Now we can work backward from this fixed point. If the final composition is 98% water and 2% dry matter, and we have exactly 1 pound of dry matter, then 1 pound equals 2% of the total weight. To find the total weight equals 1 pound divided by 2%. That's 1 divided by 0.02, which equals 50 pounds. Let's verify this answer. Total weight, 50 pounds. Water weight, 98% of 50 equals 49 pounds. Dry matter, 50 minus 49 equals 1 pound. Water percentage, 49 divided by 50 equals 98%. The mathematics check out perfectly. Our 100-pound sack of potatoes has become a 50-pound sack of drier potatoes. Let's explore this paradox through several mathematical lenses to truly understand why the answer is so counterintuitive. Let W equal the final weight of the potatoes. We know final water percentage equals 98%. Final water weight equals 0.98 times W. Dry matter weight equals 1 pound. Constant. The total weight equation, W equals 0.98 W plus 1. Subtracting, W minus 0.98 W equals 1. 0.02 W equals 1. So W equals 1 divided by 0.02, which is 50 pounds. Here's another method. Let L equal the pounds of weight lost. We know starting water equals 99 pounds. Final weight equals 100 minus L. Final water percentage equals 98%. So final water weight equals 0.98 times the final total weight. 0.98 times 100 minus L. Weight loss equals starting water minus final water. L equals 99 minus 0.98 times 100 minus L. Simplify. L equals 99 minus 98 plus 0.98 L. So L equals 1 plus 0.98 L. Subtracting. L minus 0.98 L equals 1. 0.02 L equals 1. So L equals 50 pounds. Therefore, final weight equals 100 minus 50, which equals 50 pounds. The paradox is solved. Human brains evolved to think linearly about quantities. If you see 3 tigers and 2 run away, you have 1 tiger left. If you gather 10 berries and eat 1, you have 9 berries left. This linear, absolute thinking served our ancestors well for millennia. But proportional relationships are nonlinear. They involve feedback loops where changing one variable affects the very system that defines the relationships between variables. Our brains haven't evolved sophisticated intuitions for handling these feedback systems.